Good afternoon, everyone. How are you all? So please keep a hi in the chat box so that we got to know that how many of you are here. Please confirm by hitting a like button. Okay. So as you know that we had already conducted the lecture one, which was happened yesterday, and that we have seen a quite of things related to the gate exam. Means we have we have gone through the syllabus, and we have gone through the important topics that are related to the gate exam. And if you cover all those topics, definitely you will going to have a good marks in the electrical machine. All right. So how many of you are here? Please say hi, and also press a like button as well, and please share the session link with your friend and your colleague so that they also get a benefit of the session at most. All right, and those who are not aware, please tell them to come on a priority basis. All right, so that we will be having a healthy competition. All right, healthy competition in terms of the question and in terms of the content. All right. So as you know that the IMS GATE Academy has come up with an initiative which is the foundation course, and we had started this with the past week, you can say, and we have covered a lot of subject, not only with the EE, IN and AC stream, also with the other respective stream like mechanical, civil and all others. All right. So those who are belongs to the respective stream, they can visit to our IMS YouTube channel, and with respect to their stream, with respect to their subjects, and with respect to your favorite faculty, you can visit to the playlist and enjoy the lectures over there. All right. So do it fast. Hit the like button and share the session link with your friend, and also do subscribe our YouTube channel if you have not yet subscribed, so that you will going to get most of the things from us, and also press the bell icon so that whenever we are come up with the live session, you will going to be notified instantly. Okay. So as I hope you are aware that I'll be taking the electrical machine here, and that is belongs to EE and IN stream, and in the lecture one we have completed all the things. All right, as I have told you, and in case you have not gone through that lecture, please do visit the lecture, and you will definitely going to enjoy the lecture one also. In this lecture, basically we will going to discuss about the electrical material, which is an important criteria or important topic with respect to the GATE exam, and this is highly recommendable for the engineering services, or you can say Indian administrative kind of exam. All right, the electrical material basically will going to be the theoretical kind of thing, and the theoretical are very less. Means if you talk about the number of question in terms of the theoretical part, the GATE has a very less number of question. All right. So whatever question that we are having is mostly the numerical and the MCQ type question, or you can say that mostly the numerical or the conceptual type of question. That the theoretical question are very less in the GATE exam. All right. So mostly these topics are related to the development of the basis, the development of the basics that you are going to be study in your academic level. I hope all of you have already studied this some portion of the electrical machine, which is also known as the basic electrical machine. I hope you have gone through the BL Thareja book, which is mostly referred by the student when they have entered into the engineering, isn't it? So in the first year they have a subject which is a basic of electrical engineering. So in that you will going to find a lot of things. Gopal Rao, good afternoon Gopal. So in the electric in the basics of electrical machine, you will going to discuss about a lot of things with respect to electrical material, with respect to magnetic material, laws, rules, and so on and so forth. So all those things we will going to cover in this foundation course, and I make sure if you're going to attend each and every session, you would going to like the session, enjoy the session, and definitely you can solve each problem which has been asked till date in the from the electrical machine. All right. So do share the session link with your friend, and let us start with the topic that we are having here, which is lecture number 2, electrical material. All right. So what do you mean by electrical material here? So as the name itself says, that the electrical material which is having the property of electrical. Now the electrical basically are used when we are having the flow of current. All right, the flow of current. So the material which is having the phenomena, or which is having a tendency to make the current or the charge to flow within themselves, is those kind of material is known as an electrical materials. So how many electrical materials that you are knowing? Please let me know. How many types of electrical material that you are currently knowing? Anyone? The answer could be wrong, but that hardly matters. I want only a name. What electrical material basically you are knowing? So definitely the electrical material, as I told you, the material which allows the flow of charges or the flow of current. All right. So the flow of current is basically possible in the case of conductors. So conductor is a kind of material, or the material which is having the property of the flow of current will be known as an conductor. So the electrical material is basically classified into 3 types of things. All right, 3 types of things. The first one, conducting material, as I told you, which allows the flow of current. Insulating material. So what do you mean by insulating material? The material which does not allow, please listen me very carefully, the material which does not allow the flow of current. Can I have an example of the insulator? Yes, the example is wood. Wood cannot allow the flow of current. Next one, the magnetic material. So the material which allows the flow of magnetic field. So depending on our working, yes Gopal, excellent. So depending on the phenomena of the flow of electric charges, phenomena of the flow of magnetic field, and phenomena which does not allow the flow of current or also the flow of magnetic field. So let me summarize. The flow of current is possible in the conducting material or the flow of charges. Magnetic material, the flow of magnetic field, and which does not allow either of these two is insulating material. Now why we require these 3 kind of material? So depending on the convenience, depending on the requirement, we are having these types of material. I hope you have heard about a device which is a transformer or a synchronous machine. Definitely we will going to see a synchronous machine, induction machine, and a DC machine. The induction, DC, and synchronous machine will have 2 parts, a stator and a rotor. Stator is basically a static part of the machine, and the rotor is what? Rotating part of a machine. So one is stating and one is rotating, and in between these two means the rotor has to be moved freely. So definitely we will have to give some space or an air gap between these 2 parts. So if there is no electrical connection, or if there is no any physical connection between these 2, then how the power will going to be transferred? The power in that case is going to be transferred by the help of magnetic field. By the help of magnetic field. Am I clear? So basically, in every machine, magnetic material will going to be help us to transfer the magnetic flux, whereas we require the physical connection so that the power, the electrical power should transfer only with the help of current, with the help of physical connection between the parts. We will be having the conducting materials. Done. So I hope I have given you some idea about this material. Let us move ahead and discuss one by one in detail. So basically in this session I will going to cover the conducting material, and in the next session, which is lecture number 3, I will going to discuss the magnetic material. So those who are not aware about the playlist, you can find the playlist in our YouTube channel. All right, in our IMS GATE Academy YouTube channel, and you can find the number of lectures in the playlist of the respective faculties, and according to the date you will have to come up here, and so that you should not miss any lecture. All right, so let us enter into the first material, which is a conducting material. Now, what do you mean by conducting material here? So conducting material here is what? It's basically a kind of conductor, and I told you what is conductor, which allows the flow of current or the flow of, just a second, or a flow of electric charges, done, or the current through it with a minimal resistance. Conductor are high electrical conductivity, which means that, this is very important point, which means that they can facilitate the movement of the electric charges, typically electrons, along the surface or through their bulk. What do you mean by this statement? The electrical charges can flow through the wire within the surface or within the material. I hope you have heard about the word which is proximity effect, which is proximity effect, and one more effect we will going to study in the power system, which is known as skin effect. So whenever a current is hovering around the surface of a material, then that is known as an skin effect, which is not a desirable property of any electrical material. We want electrical current to flow within the material so that the heat dissipation or the flow of current will be maximum. As we know that power is what? Voltage into current into cos phi. So electrical power is directly proportional to the current. So whenever the current is higher, the electrical power will going to be higher. So because of that, the current has to be transferred throughout the material, not only within the surface. All right, so this is the drawback of any material, and we should not choose such material which are having such kind of phenomena. All right, so in so cases, the skin effect and the proximity effect has to be nullified. All right, now let us move ahead. What kind of materials that we are having? So basically, the conductor is what? A metal which allows the flow of current. So we are having the 4 kind of metals: copper, aluminium, gold, and silver. So these are most commonly types of conducting material, and we can choose any one of these 4. Done. All right. So why these are heavy? Why we are going to choose this kind of material for our conductivity for the flow of the electric current? Because these are having some properties here, which is a high conductivity, Done. It is having the thermal conductivity as well. It is having the ductility. I will explain each and every one in detail, but as of now, please look out the important properties of the metal over here. And the next one is the malleability, which makes them suitable for the various application, including electrical wiring, electronic components, and the power transmission and in the communication system. So the metals has a vast variety of its application in all those things. Now coming back to the materials, since suppose I am giving you a 4 kind of metals, then to make any machine, which kind of metal you will going to choose? Which kind of metal you will going to choose? you'll be having a choice of copper, you'll be having a choice of aluminium, gold, as well as silver. Being a designer, I must not choose the gold and silver. But the gold and silver is having the high number of conductivity among these two, copper and aluminium. I'm repeating again, the gold and silver will have a high conductivity. Conductivity means the flow of charges or the resistance offered for the flow of charges is minimal. Got the point? So, why I am not able to choose gold and silver since this is having the high conductivity with respect to copper and aluminium? The two factors that I'm going to put up here is that first one, pricing. As you know that the gold price is hitting high and a high, isn't it? Currently the gold price, I think 61,000 per 10 gram. So if you're going to make if you're going to make such a machine which is having the gold, and in the same way the silver, I guess it is having around 55,000. All right, it is varying between 50 to 55,000 per 10 gram. So such high amount will is not economical with respect to consumer. I should not buy. Being a consumer, I will not going to buy such high amount of machine. Means the machine which is having such high price, I will not going to buy. Then what is the use of making the machine if you're going to choose this metal? Done. And what is the second point? The second point is the availability. Since the gold and silver are available in a less amount in the current scenario, means the availability of gold and silver are very, very rare. And because of that, the price is going to be further higher. So these two factors makes the price to be higher, and therefore it will leads the machine to be on a higher side. Means I'm talking in terms of price. Done. So this is the reason why we are going to ignore gold and silver, but you should keep in mind that if we are having an abundance of the gold and silver, then definitely we will be going to choose gold and silver. Is it clear? Because of the conductivity. Let me talk about the conductivity here. Conductivity which is represented in terms of sigma. So sigma of copper, sigma of aluminium, sigma of gold, and sigma of silver. Okay, sorry, this is Ag. Okay, so this is the conductivity of the individual. Now, if you talk about the priority, just a second. Okay, one second. So conductivity of aluminium is very less, whereas copper will have on a higher side, then the silver will come, then gold will come. Done. Well explanation about conductor, sir. Thank you, Gopal. So suppose in some state exam, if you have given these 4 choices and you have been asked to choose the highest conductivity material, then you will be choosing the gold. All right. So these are the priority of the metals with respect to their conductivity. So let us move ahead. So let us come into the highly conducting materials. So earlier we discussed about the conducting material. In this we will going to discuss about the highly conducting material. So what do you mean by highly conducting material? The material which are highly conductive in nature is known as high conducting material. What do you mean by this? Means the flow of electric current, the flow of electric charges is on higher side, or you can say the resistance offered to the flow of current is very, very low. Such kind of material is known as highly conducting material, and those material are written over here. Done? Now see, the high conducting material, which is further known as conductor, are the material that allow the electric charges to flow freely through them. Done? Next one, a high conducting material is a material that has a high electric conductivity which allows electric charges to flow easily through it. So basically this point, the first one and the second one both are same, and the third one, the example is copper, silver, aluminium and gold. As well as along with this, Atul, good afternoon. Okay, good afternoon, Atul. So as well as some non-metallic material like graphite. See, this metal we will going to use in DC machine. Why we are going to use, I will let you know after some time. But as of now, please keep in mind that the graphite is also a kind of conductor and some types of conductive polymer. Done. Next, these material are used in a wide range of application including electrical wiring. I hope you know what is electrical wiring. You have heard about a word soldering, isn't it? Means if you want to connect one end of a metal with the other end of the same material or some different material, so by the help of some soldering, you will going to attach those end point, which is known as soldering. All right. So basically, those kind of thing is electrical wiring. Then electronic components, power transmission and communication system, where they have ability to efficiently conduct electricity, which is essential. All right. Now next property of the highly conducting material is, this is what the property of the highly conducting material. Earlier we have discussed about the significance of the conducting, means highly conducting material. Here, what are the properties that has to be carried by the highly conducting material? So the first property is highest conductivity, means the number of electrons to be flow through the material has to be on higher side. So whenever the number of current is higher, then it is known as highest conductivities. Done. It is having less temperature coefficient. So what do you mean by less temperature coefficient? See, resistance means any material, any conducting material or any metal will have its resistance, and which is given by R equal to R naught 1 plus alpha del T. What is R naught? R naught is the resistance at the room temperature. Del T is the change in temperature. Suppose currently the temperature is 25 degrees centigrade, and under this the R naught is, let us say, 1 ohm. I am taking only the example. Under 25 degree centigrade, the resistance is what? Let us say 1 ohm, which is R naught. Now, if you increase the temperature, or if you are taking this same metal to some different places, let us say some hot places, then definitely we will be having the temperature on higher side. So let us assume the temperature is 50 degree centigrade. So the initial temperature was 25 degree centigrade, and this time the temperature is 50 degree centigrade. So the difference between these two is what? Del T. So whenever you are taking this material to some different temperature, then at that particular temperature, what will be the resistance will be given by this. And what is alpha then? Alpha is the temperature coefficient of resistance. it tells you that what will be the increment. Please listen me very carefully. What will be or what would be the increment in the resistance per ohm per degree centigrade. So those who are having the less number of temperature coefficient, those will be considered as highly conducting materials. Am I clear? So this is again one requirement for making the for choosing the conducting material. Let us move ahead. Adequate mechanical strength and absence of brittleness. What do you mean by adequate mechanical strength? Suppose you have a wire, and you want that wire to be put up under the machine, and definitely those wire will carry some current. What if those wire will break easily? Can it make a circuit complete? Do you want to choose such material which can break easily? No. If those wire can break easily, then those will be undesirable property of the highly conducting material. So we want our material to be on higher mechanical side, or means I mean to say higher mechanical strength, and also the brittleness has to be lower or ideally absence. So such that whenever a current will flow, and in the high power application the current will go like 500 ampere, 1000 ampere and so on and so forth. So such amount of current will make the wire to be heated up, and it will going to break the wire, and which makes the circuit incomplete, and you will not going to means the machine will not going to be function further. So definitely we choose such a conducting material which is having high mechanical strength and low brittleness. Next property is the corrosion resistance. Corrosion resistance. So I hope you have heard about the corrosion. What do you mean by corrosion? Whenever a metal or whenever an iron piece or magnetic material is kept under the influence of the air, then it will going to be corroded. This means that whatever property that earlier those material is having, it will going to lose. So the material has to be low corrosive in nature, or you can say ideally zero. Then next, good mechanical strength, that we have already discussed here. Next point, good electrical stability. Alright, high reflexibility. What do you mean high reflexibility? See, some high conducting materials such as silver and copper has highly reflective and often used in mirror, reflective coating and other optical applications. Just like in your measurement, we are having a phosphor coating, na? Means whenever the electron is striking the screen of the CRO, cathode ray oscilloscope, it will reflect the electric current, or whenever it is striking the phosphorus or a screen of the CRO, you will going to see a light up on the screen. So such kind of material is highly reflective in nature. So one kind of that is silver and copper. Now next property is low electrical resistance. As I have told you, suppose you want to go from one place to another place, and you are having the two choices. One road will have a 10 number of breakers, all right, jumpers, you can say 10 numbers of breaker, and the other route is having only one breaker, you can say, all right, one breaker. So which path you will going to choose? 10 number of breakers or one number of breakers only? Definitely you will going to choose a less number of breakers, so that you will reach to your destination as quickly as possible. In the same way, the electron or the electric current always try to choose a low resistance path, and this is only possible in case of conductor which is highly conductive in nature. Then next is ductility. See, High conducting materials are ductile and can be easily drawn into wires, making them ideal for using electrical wiring. See, bacha, uh, the raw material, you can say, the raw material of copper or aluminum, any kind of material you're going to take. The copper and the aluminum which initially you are going to take is not have its application in the electrical machine. All right. Why? Because the copper and the aluminum has to carry the current, and the current can only be possible if we make them in a wires. See, in my room we have a light. So light means why this thing is going to be light up, because the electric current is coming into this device, you can say. So definitely with the plug means wherever you have a socket, in that you will going to plug up, and with that plug a wire is coming out to that particular device. So basically that wire is what a kind of is basically a copper, and in that copper a current is flowing. But whether such kind of or you can say the such length of wire is easily available in the nature? No, we will have to make such kind of or such a vast length of wire we want. So for that we will have to mold the copper into wiring form, and the property is known as ductility. Done. What is next? Malleability. What do you mean malleability? They are the malleable and can be easily shaped into the various form for different application. I hope you have seen the transformer. I hope you have seen the transformer. In the transformer, basically we have a thin layer of frame. Thin layer of frame. So I can make a copper. Suppose this is a copper which is having the random shape. So you can mold this random shape into into a wire, or you can also make or mold this random shape into a kind of thin sheet like this. This is sheet and this one is wire. Done. So that this wire can have its own application on the electrical machine, and this sheet have its own application in the electrical machine. The wire we are going to use in case of winding, and this sheet we are going to be used in case of transformer. All right. So let us come to the material that we have discussed is copper, and let us see the some properties of the copper here. The properties of the copper is that it is a high electrical conductivity, isn't it? It is having the high electrical conductivity. Next, it is having an excellent thermal conductivity that we have discussed. Next one, it is having the ductility and the malleability. This we have already discussed in the highly conductive material. Next one, just a second. Next one is the corrosion resistance. Definitely the copper is having its advantage as corrosive resistance. Done. Any doubt? So these are some properties of your copper. The next property is the temperature coefficient. This is very important property. The temperature coefficient of resistance, which is TCR of copper, is approximately 0.00393 per degree Celsius. This seems to be low, but my dear friend, this is very high. This is very high. For insulator or for a highly resistive element, the temperature coefficient resistance will goes to in terms 000 or sometimes quadruple zero. Now this is considered to be a very low. Am I clear? So by looking into the number, please do not assume that the temperature coefficient to be low. No, such number is very, very high. So let us move ahead. The copper has a slightly higher temperature coefficient of resistance than aluminium, but the difference is relatively small. The TCR of the copper is very depending on the specific alloy and manufacturing process used. So here one term has been introduced, which is alloy. What do you mean by alloy? Alloy means whenever you are going to mix up two different material, basically the two different material will have to be in conductive in nature. So whenever you are going to mix a two material or more than a two material is known as alloy. Now what is the use of alloy? Definitely the alloy will have a less conductivity when it is compared with a highly conductive material. Then is there any practical application of the alloy? Yes, it has its practical application. And what is that? Let me write here. Alloy is basically what? Mixture or amalgamation of two or more elements. Then now what is the practical application? Basically this alloy will have the low, or it is better to write high resistance. This means that the conductivity of this is low. Conductivity of an alloy, I am talking with respect to conducting material, will going to be low. Now what if the resistance is high? If the resistance is high and you are going to, suppose if you are going to flow the electric current through this alloy, what it will going to have? It will going to heat up. Heating. How, sir? Suppose in that alloy the current is I, then power loss for certain duration is what? Heating, na? So I square R, this is power into time. This is known as heat dissipation. So whenever this resistance is high, the material, the alloy will going to be heated up, and wherever you require the heating kind of application, we will going to use this alloy. And may I know any kind of such device? Yes, that is iron. आयरन को प्रेस, मतलब आयरन को यूज करते हो ना प्रेस के लिए, एंड द बेस ऑफ दैट आयरन इज व्हाट? हीटिंग मटेरियल. सो द बेस ऑफ दैट आयरन can only be made with alloy. It is never going to be made with the copper or aluminium or silver or gold, because the resistance of that material is not very high. So if the resistance is not very high, it will going to have a low heating. But to press any cloth or any kind of thing, we require a high heating kind of thing. All right. So this is only possible in case of alloy. So from now onward, if someone you going to ask that what type of material that we have used in our iron box, then you will going to say we have used there as alloy. Done. So let us move ahead with the next kind of material, which is aluminium. So what is the property that aluminium that we are having which distinguishes it with the copper? The first one is the lightweight. Aluminium has a low density, which makes it lightweight when compared to the other metals such as copper and steel. All right. So the aluminium will have has a lightweight property with respect to copper and steel. This makes it a popular choice for application where weight reduction is important, such as in automotive and aerospace industry. So mostly in the aerospace and in the automotive industry, we are using the aluminium, not the copper, not the gold, not the silver, not the steel. All right, now please let me know what in the power system, in the power system, where we are using this aluminium. I hope you have seen the transmission line. A tower basically in between the two tower like this. Suppose you have two electrical towers. I hope you have seen the upper end of this tower are connected by some material. So this material is what basically is an aluminium. All right. Now, why we have make this this connecting wire in terms of their aluminium? Why we have not chosen a copper? Because the aluminium is having the low cost or cheaper than the copper. सोचो अगर मैंने यहाँ पे कॉपर लगा दिया और एक और आपके पास इलेक्ट्रिकल टावर है, इन दैट आई हैव कनेक्टेड दिस टावर विथ कॉपर, then definitely I will going to install this copper, not the aluminium. Why, sir? As I told, the copper is going to is having the high what to say, the rate of the copper is higher when it is compared with the aluminium. So this is a reason why, means this is one of the reason why we have not used the connecting material with copper, rather we have used with the aluminium. Done. So let me rub this thing. Next one is the good conductivity, but as you know that the conductivity of the copper is higher than the aluminium. So with respect to the other metals, the conductivity is on higher side, but not with the other three: gold, silver and copper. All right, with respect to that, it is having the low conductivity, but with other metals it is having the higher conductivity. Done. And again it is having the resistance towards the corrosion, and the ductility that we have already discussed is also on the higher side. Next, the aluminium is again have a high strength, basically high strength to weight ratio. So when suppose you are going to increase the weight of certain material, so definitely it will going to lose its strength. See, being a human, if I going to stress a lot, then definitely the strength of you will going to be lower, isn't it? Means studying for 1 hour, suppose your capacity of studying is 1 hour, and I told you please study for more than 1 hour, then definitely you will say that sir nahi ho payega, isn't it? So if I give you more weight, then definitely, or a more stress, definitely it will going to lose its strength property. So one of the best property of the aluminium is that it is having high strength when the weight is given, and it will have the properties of this with respect to copper and with respect to aluminium, with respect to copper, with respect to gold, with respect to silver, it is having the higher strength to weight ratio among all the metals. So this is again one of the reason for choosing the overhead wire for the power transmission. All right, next is low melting point, and the temperature coefficient of the aluminium is somewhat lower than the copper, but such kind of temperature coefficient is negligible. But due to advantage of the other thing of the copper with respect to aluminum, we have gone through the metal which is a copper. All right. Now, if I talk about the temperature resistance coefficient, the aluminum is having 0.0039 ohm per ohm degree centigrade, whereas in the copper the alpha was 0.00393 ohm per ohm degrees, ohm per degree centigrade. Done. So the change is minimal, but due to some other advantages of copper over the aluminum, we have chosen the copper as an conducting material. Done. All right. Here let me add a page and let me give you some comparison between the aluminum and copper. Just a second. So here parameter, then aluminium, then copper. Okay, on certain parameter, we will going to see the advantage of copper or the aluminum over the other. So the first one is the cost. Okay, so this is serial number. The first one is the cost. Okay, so the cost of aluminum, if it is 1, I'm here I have taken the ratio. Please do not think that, just a second. Please do not think that the cost is 1 here. Okay, so please do not think that the cost of aluminum per gram, per milligram or per kg is 1. No, I have taken here only the ratios. So suppose if the aluminum cost is 1, then for the copper it will be 2.041. 2.041. So this is what? This is the cost, and due to the cost effectiveness, we have chosen the overhead wire with aluminum. Next one. Is the cross sectional area. Just a second. The cross section area. So the cross section area of the aluminum, if it is taken 1, then for the copper the cross section area will be 0.6173. This 6173. Next one. Next one is the diameter. Suppose if the diameter of the aluminium is 1, then for a copper it is 0.7857. 0.7857. Next one, fourth, that is volume. Volume. So volume, if it is 1 for aluminium, then for copper it is 0.485. 0.485. Fifth one, is the weight here. Fifth one is the weight. Suppose if the weight of aluminium is 1, then it will be 2.041 for the copper. And the last one is the strength. If this is 1, then for copper it is 1.56. Okay, so here, just a second. So here, cross section area, or you can say the diameter, if this is d equal to r by 2, sorry, not d equal to 2 times of r. R is what? Radius. R is what? Radius. Then the cross section area is proportional to r square, radius square, and your volume is proportional to r cubic. Alright, so basically this is r square times and this is r cubic time. Now let me discuss this second point, cross sectional area. Why the cross section area of the aluminium is on higher side when it is compared with the copper? Now as I already discussed that the conductivity of aluminium is less than conductivity of copper. Now for the same resistance, means to have the same losses in a device or in a machine, then resistance has to be same, isn't it? For same resistance. For same resistance. So resistance is what? Basically rho L by A. Rho L by A. So resistivity of aluminium, resistivity of aluminium, length of aluminium and area of cross section of the aluminium. Just a second. This is aluminium, and the resistivity of copper, length of copper and area of cross section of the copper. If these all things are equal means if together means all the three, when it becomes equal, then the resistance of the individual will going to be equal as well. Now let us assume, let the length of material is same. That is, length of aluminium is equal to length of copper. Then length will going to be cancelled out, and resistivity of aluminium is divided by area of aluminium is equal to resistivity of copper divided by area of copper. Now what is resistivity? It is the reciprocal of the conductivity. Alright, resistivity is what? Reciprocal of the conductivity. So conductivity of aluminium, area of cross section of aluminium, this becomes equal to conductivity of the copper, area of cross section of the copper. Why? Because resistivity is 1 upon conductivity. High resistivity means high resistance, which further means the opposition or the resistance for the flow of current is higher. If the conductivity is high, means opposition for the resistance the opposition for the flow of current is lower. So basically the resistivity and conductivity both are opposite in nature or reciprocal of one another. Done. So this is the reason why I have written like this. Now see the point first, this one. From here, this will gives you area of cross section of aluminium, which is equal to what? Sigma of copper divided by sigma of aluminium times aluminium of copper. Sorry, not aluminium, actually sorry, that is area of copper. Now from the point 1, since aluminium conductivity is less than conductivity of the copper, this makes that area of cross section is greater than, area of cross section of aluminium is greater than area of cross section of copper. Done? Any doubt? So this is the reason why if this is 1, then the copper will have less cross section area. Now what we understand with the area of cross section, let me add up one more page. See, the advantage of the cross section area means a choosing of wire which is having a low cross section area is basically on the construction side. If the size of the machine is less, then the material that we are going to use for it will going to be less, and therefore the cost of that machine will becomes less. Now see here, in an electrical machine we have two parts, as I have told you, a rotor and a stator. Now to wind up your wire over that machine, we require some kind of slots. What is that? Suppose, see here, your stator just a second, let me make here. Your stator will have, okay, just a second. Will be constructed in this way. See, just a second, let me make it. Outside we have outside we have air. This is air, all right, and this is what? This is a material that we are having here. Okay. Just a second, it is completed. Okay, so this is what? This is your stator. Now, in the stator, this is a material, okay? This is a closed packed material, and outside we have an air. So definitely we will going to insert and wire with a slot. So say this is a gap. This all thing are gap, and this is some kind of material, let us say, which is iron, aluminum. All right, sorry, not an aluminum, which is an iron. So in the air gap, basically what we are doing, we are inserting the copper wire or aluminum wire so that it can carry a current. So wire will be wounded in this manner. See, like this, and from the end it will go like this. It will go like this. Okay, basically this machine will have a three-dimensional structure. So from the end, the machine is what? Is in cylindrical shape. In the yesterday lecture, I have showed you one diagram. So basically those machine is in a cylindrical shape. So this is placed in a cylindrical manner. So from the wire will come from here and it will move out from here, and from the end it will be like this. Done. Again, suppose the direction of current is like this, I and I. Then further more, the same wire will come here, sorry. The same wire will come here and it will go to the next slot, and from the third slot it will move out like this. And from the end it will come like this, again it will go like this, again it will go to the next slot, it will be like this, and so on so forth. So in all the slots, the wire will going to be placed. Done. Now suppose if you choose the wire, of aluminium, then definitely it will have the higher cross sectional area, and for higher cross sectional area this gap has to be wider when it is compared with the copper. Okay, so whenever you choose the wire to be of the aluminium, the slots or the gap has to be higher. Therefore the size of the machine will going to be higher and the cost of such machine will going to be higher, and which is not economical for consumer. This is the reason why for making the windings or making the current carrying wire we use a copper, because the cross section area of the copper is low, and for low cross section area the slots will going to be lower, and thus the size and the cost of the machine again will going to be on a lower side. All right, so this is what basically this was stator. Any electrical machine will have two parts, stator and rotor. So this is the stator. In the same way we are having the rotor. In the rotor also we have these slots and this winding also. All right, let us move to the next thing, which is the comparison. So whatever thing that I have discussed in the last top slides, which is this one, just a second, that I have given in the form of table. Okay, done. So you can read all the points here. You can read all the points. Sorry, you can read all the points which is written over here, and you will going to come to know that what are the benefits or the advantage of copper as well as of aluminum, and what are the advantage of one over another. All right, now let us come to the next electrical conducting material, which is the electrical carbon. Now, you might be thinking that, sir, why the carbon, means why carbon is known as the conducting material? Anyway, at the starting of this lecture, you told na we have a 4 type of material only: copper, aluminium, silver, and gold. Then how it comes? How the carbon comes under the category of a metal? The reason is that carbon brushes are, or a carbon are used in a DC machine. In a DC machine, what actually happen? See, the rotor is what? Rotating. The rotor is what? Rotating. And if you want to connect a load, then definitely whatever the load that you are having in your home, in any industry, that will be static in nature. So the power that is generated by a machine, by a DC machine, has to be transmitted to certain load. And since the load is stationary, then the power that is transferred by the machine also has to be stationary. But if the rotor becomes stationary, then the generation of power will not going to be happen. Then how we will going to transfer the power from rotor to the electrical load? It is only possible when you taking out the terminals of the stator to the outside, and that terminal has to be static or stationary, and we can do so with the help of carbon brushes. Done. So as I told you that the electrical power has to be taken out. So definitely whatever material, the power that is taking from the rotor to the, or the power that is transferring from the rotor to the electrical load, so that material also has to be conductive in nature. Then we could have used copper instead of carbon brushes, or aluminium instead of carbon brushes. Why we have used specifically the carbon brushes? Any reason? Definitely has to be some logical reason, na? Otherwise we could have used the copper or aluminium. Why we have gone for the carbon brushes? The reason is that on the the carbon brushes that we are using here is basically the of one kind of form of the carbon, which is known as a graphite. Means when you are going to be amalgamate the graphite, then the graphite which is having the high conductivity will be what? Will be considered as the use of the brushes. Alright, so this is not a carbon, basically this is the one form of the carbon, which is a graphite. Alright, we can also use some other form of carbon, but due to the price constraint we are using the graphite. Now these are having one property. The property is that it is having high electrical conductivity, which is required, because if the current is not transferred from one end to another end with smoothness, then there will be a loss of power, which we should not want. So definitely we require such high electrical conductivity material, which is the carbon brushes or a graphite, you can say. Next, it is having low coefficient of friction. Now as I told you, whenever we have a friction, then definitely due to that friction the energy will going to be lost. If the energy will going to be lost, then the power will going to be lost, and whatever the power that you are generating, if it is losing the power, then such kind of device is not admissible. Okay, so since the carbon brushes is having low coefficient of friction, this makes the better choice of brushes. And next one, the good thermal conductivity. What do you mean by this good thermal conductivity? As you know that for higher power application the current is high. So if the current is high, then definitely definitely to bear such high amount of current, the thermal conductivity of the material has to be higher. Done. So such kind of property is possible in case of carbon, or you can say graphite. Then the next property is self-lubricating. All right. So whenever the material that we are going to be used over the period of time, it will lose its, what to say, the characteristic or the significance. So whenever the material is using for the you can say for over period of time, then definitely any material can lose its property. But if the material is losing its property, then it will going to be create a problem in the machine. We should not want that. We should not want in any case. So what do you mean as self-lubricating? The self-lubricating property of the carbon is one of the greatest advantage among other. Over the period of time, means whenever the machine is working over the period of time, it will going to reduce the friction. So whenever the friction will going to be reduced, we can easily transfer the energy from one side to another side, or without a much loss of energy, we can easily transfer the power from one side to another side. And this is only possible when we have a self-lubricating property of a material. I hope this point is clear. All right. So the carbon will have this self-lubricating property. Next one is the chemical resistance. Just a second. Chemical resistance, easy to replace, and abrasion resistance. All right, so these are certain properties of the brushes that we are having, and such kind of brushes, I hope you have understood well that why we have not chosen the copper aluminum instead of brushes. Am I clear? Instead of carbon, why we have not chosen the copper and aluminum as brushes? Done? All right. So with this, we have completed all the things which are the essential requirement for the basics for electrical materials. So in the next lecture, we will going to start the next material, which is what? Magnetic material. And in that we will going to discuss a material which will allow the flow of magnetic field, and definitely those lecture you will going to enjoy. Okay, so I hope you have liked the session, enjoyed the session, and if you do so, please like the session as well as share the session link with your friend, and also subscribe our YouTube channel, and also press the bell icon so that you can instantly notify the upcoming session that we are going to be conducted. All right. So with this, let me end the session, and we will going to meet on tomorrow, and in that we will going to start the magnetic material. So bye bye, and take a very good care of your health.